A matrix is simply an arrangement of objects in rows and columns. Here, A, B, C, and D are elements of the matrix A. The diagonal from top left to bottom right is called main or principal diagonal, and the diagonal from top right to bottom left is called secondary diagonal. You can use square brackets as matrix brackets or enclosing brackets, but we shall use parentheses for now. If you use vertical bars instead, you get representation of determinant. A determinant of a 2 by 2 matrix is defined as the product of principal diagonal minus the product of secondary diagonal. Now let's use matrix to solve a system of linear equation. Let us start by taking two general linear equations. Multiply the first equation by b2 and second equation by b1. Subtracting equation 4 from equation 3 gives the following equation where terms with y cancel out. Let's rearrange and solve for x. The expression in numerator is just the determinant of blue matrix and the expression in denominator is the determinant of red matrix. Similarly, you can multiply equation 1 by a2 and equation 2 by a1 and subtract to get expression for y. Here, denominator cannot be 0 since division by 0 is undefined. Let's use different notation to denote the determinants. Dx for blue determinant, dy for green determinant, and d for red determinant. Now let's rearrange everything and solve some questions. Let us start with the first question. First equation is 2x minus y equals 3 and the second equation is y plus 3x equals 7. We need to rearrange the second equation to form ax plus by equals c. Now let's note down the coefficient and constants. Let's calculate d using matrix made up of coefficient of x and coefficient of y. Dx by using coefficient of y and constant. Dy by using coefficient of x and constant. Let's calculate those determinants to obtain d equals 5, dx equals 10 and dy equals 5. And using our formula for x and y, we obtain x equals to 2 and y equals 1. Let's try a harder looking question now. This question isn't in the standard form, so first we start by converting it into standard form. Now this question is same as previous one and you can solve it. In this question we have x and y at denominator. The equation is actually in standard form if we consider 1 upon x and 1 upon y as value to find. Start by keeping track of coefficients and constants like before. Next, calculate the determinants required. Now we use the same formula, but since we used coefficients of 1 upon x and 1 upon y, we get values of 1 upon x and 1 upon y. We can find x and y by taking reciprocal. Let's solve one last system of linear equations. This one looks quite different. Dividing both sides by xy gives something familiar. This is the same as previous question. Now you know Cramer's method.